So, using the stopping potential, you should be able to find the maximum kinetic energy among all those photoelectrons. The stopping potential is independent of the intensity of light. The intensity of light only affects the number of photoelectrons emitted. And even if there is only a small number of photoelectrons emitted, there may be one which has the highest kinetic energy just to reach the collector on the right hand side. And that explains the first diagram here, that the stopping potential never changes even if the light intensity is increasing. The light intensity increase only increase the number of photoelectrons produced, and so to make the current larger. On the other hand, when the frequency of incident light increases, the stopping potential also increases, because the higher frequency of light means the higher energy of light particle, and this will make each photoelectron more energetic. So it would be even harder to stop the highest energy photoelectron. And that's why in the diagram, when violet light is used, then you have to apply a even higher stopping potential. On the other hand, for green light, smaller stopping potential. For even longer wavelength, lower frequency, red light, then the stopping potential is even smaller. These three curves refer to constant intensity cases, that is, the intensity of red light, blue light, and violet light are all the same. As for red light, the frequency is lower, then there should be more number of light particles in order to produce the same intensity. When there is more number of light particles, that is more photon, then there will be more photoelectrons produced. On the other hand, when the frequency becomes higher and higher, then each light particle, that is photon, has higher energy. But then there should be less number of photon in order to produce the same intensity. When there are more photon hitting the metal plate, there can be more photoelectrons emitted. When there's less number of photon, then there will be less number of photoelectrons emitted. In fact, intensity is the power per unit area, and that is directly proportional to the total energy of photon per second. So it would be given by N, which is the number of photon hitting the metal surface per second, multiplied with energy of each photon, HF. So when frequency increases, for example, from red light to violet light, then energy of each photon, HF, increases. In order to make the intensity constant, then the number of photons hitting the metal surface should decrease. So just now we have revealed the theory to explain photoelectric effect, that is, by using the particle theory of light, the concept of photon. But in old days, the scientists do not have that concept. They use wave theory, then they cannot find explanation of photoelectric effect. Because according to wave model, the energy contained in a wave only depends on its amplitude. And the frequency doesn't matter, so there should be no difference between red light and violet light. So immediately, the wave theory cannot explain the existence of threshold frequency. The wave theory cannot explain the difference between red light and violet light. By using wave theory, the electrons on the metal surface should take time in order to accumulate to collect enough energy from the light before they may leave the metal surface. However, in photoelectric effect, there is no such time delay, as far as there is light of high enough frequency illuminate on the metal surface, photoelectrons are emitted almost instantly. There is no such time delay. Lastly, according to wave theory, when the light intensity becomes higher, that is, the amplitude of light wave becomes larger, there should be a higher maximum kinetic energy amongst the photoelectrons. However, the maximum kinetic energies of the photoelectron does not depend on the intensity of light, but it only depends on the frequency of light illuminate on the metal surface. So, using photoelectric effect, you cannot explain these three observations in photoelectric effect. The first is the vessel frequency. The second is there's no time delay for photo emission. And the last one, that the maximum kinetic energy does not depend on the intensity of light, but it only depends on the frequency of light.